Alright, exponential functions. You know what exponential function is?
Nope. Function that is exponential.
I'm about to find out. About to find out. It's an equation or a function that in the exponent is the variable, hence why it's called an exponential function. So a is just any number, and then the exponent has your variable. Okay, and then you're going to do some exponential functions that are called natural base functions. And this is when the number is the e to the x. And you have this on your calculator. It's approximately 2.72, goes on forever. It's kind of like pi. And on my calculators, it is second ln, and the ln's like 2 down from the second key. I don't know if you guys have calculators like me or not, but if you do, so that's that. Okay, and then we have to remember our transformations. And these are the same transformations for every single graph we've done this year. So if you're adding on the outside, so what I mean by the outside, not in the exponent, the graph moves up. Subtracting on the outside, the graph moves down. Adding on the inside, the graph moves left. Subtracting on the inside, the graph moves right. Okay, and then your negative. If you have a negative in front of the whole thing, then that's reflected over the x-axis. And if there's just a negative in the exponent, not a minus sign, but a negative in front of the variable, that's reflected over the y-axis. Okay, all of these graphs have asymptotes. I'm not going to have to draw the asymptote, you're not going to have to find it necessarily, but you're going to see that all the graphs kind of taper down. Well, they either start low and they go high, so they're an exponential growth function. Bless you. So this would be like, that's a growth function. Or they start high and they go down like this, and that's a decay function. Okay, so they all kind of taper off. Most of the time they're at 0, but you'll be able to tell when the numbers start getting smaller and smaller and smaller where it's kind of going to. Or they'll start there and go up. You do not have to know whether or not it's growth or decay. Okay. Alright, so the first thing I have to do is you have to build a graph. Now, they kind of have the homework split where you do the numbers and then you kind of go through the whole thing and then you go back and look at the e's. I'm just going to combine it all together. Okay? So, the normal, I'm going to make this as simple as I can. I want to see your T-chart. You want to do 5 points. These are your normal 5 points because you want them as close to the origin as you can. If the graph has been shifted right or left, these points will change. Okay, this graph has not been. There's nothing added or subtracted in the exponent. So this is what I would call like your standard T-chart. Does everybody know how to do exponents on their calculator? If they don't do it in their head. Okay, mine has the caret button. If you can do it in your head, you can do it in your head. I don't care. Okay, so we'll just plug them in. So 1/2 to the negative second. If you want to check to make sure you know how to do this, go ahead and plug them in. You should get 1/4. Okay, and then I plug in -1. 1/2 to the negative first. This is not even true, I'm sorry.
I was just.
This is 4. Sorry.
Honestly, my calculator's broken.
No, you're right. Okay, 1/2 to negative first is +2. Okay, what's anything to the 0 power? 1, good. Then 1/2 to the first is 1/2. And 1/2 squared is 1/4. You guys didn't want to say anything because you're going to be on tape. Okay, then we're going to graph. So this is what you're going to use your graph paper for on your homework. Alright, you'll have six graphs tonight. So -2, 4, -1, 2, 0, 1, 1/2, and 2, 4. Is everybody okay with the first one? Okay, so this one, we have a -1 in the exponent, so what does that mean? It's gone up, down, left, or right? Okay, it's gone right, how many? 1. Okay, so instead of being at -2, we're going to move our graph to the right 1, which means we're going to start at -1. Okay, if you don't move your t-chart as your graph moves, your numbers are either going to be really, really high and not fit on your graph, or really, really low. You're not going to be able to see if it's a growth or a decay, because it'll be like all in a line. Okay, make sure you follow your order of operations. So you have to figure out what the exponent is first before you can take the power to that. So -1 minus 1's -2. 2 to the negative second. That one is, of course. Okay, 0 minus 1's -1. 2 to the negative first is 1/2. 1 minus 1 is 0. 2 to the 0 is 1. 2 minus 1 is 1. 2 to the first, 2. And 3 minus 1 is 2. 2 squared is 4. Okay, what do you notice about these? First one, the second one. Anything similar? They switched, right? Fractions are decay problems. Whole numbers are growth problems. You don't have to know which one's which. And then I plot my points. Is everybody okay with the numbers? Can we do the e's? Okay, now I can't do the e's in my head because e is not a perfect number. It goes on forever. Okay, when you're plugging these in, I would go like 2 decimal places just so you know where it'll be. Okay, and what would you do first? Exponents or multiply? exponents. Okay, so make sure you follow order of operations. Okay, plus 4. Right, left, up, or down? What's going on? Left 4. So instead of starting at -2, I would start at -6. Okay, if it's moving up or down, that doesn't change your t-chart. Okay, it's just if there's stuff in the exponent. Okay, so I would do -6 plus 4, so that's -2. So I would do my e to the -2nd. It equals, and then multiply by 3. So this would be 0.41. If you're plugging it all in your calculator one time, that's fine. Just make sure you're careful when you need parentheses. Okay, so -5 plus 4 is -1, so e the negative first times 3, 1.10. -4 plus 4 is 0, e to the 0 is 1, times 3 is 3. -3 plus 4 is 1, e to the first times 3 is 8.15. And then -2 plus 4 is 2, so e to the second times 3, 22.17. Okay, I'm going to assume that your graphs don't go up that high. If you want to draw your graph that high, you can. As long as you have it in the t-chart, that's fine. So we should be able to go up to 8.15. Maybe. We're out of space. 3, 4, 5, 6, -6.41. -5, 1.10. -4, 3. -3, 8.15. So is this going to be a growth or a decay problem? Just curious. Okay, are there any questions about graphing? Yes.
Okay, so we both, on all of our problems, we had the like inside ones. If it was outside, it would be like on the 3, right?
If it's outside, it'll be like this, and that will not affect your t-chart. Okay? This is just multiplied. This doesn't move your graph up, down, left, or right. It just dilates it, but it doesn't change your t-chart at all. Okay? And neither would a number if it's added or subtracted out here. It won't change your t-chart. Okay. Is there any other questions about graphing? Okay, so you have a part that's graphing like toward the beginning, and then like one that's kind of toward the end. Like goes back and forth. Okay. Alright, the next part will be describing the transformation. Now, you're looking what changes from F to G. Okay, so you're not trying to describe what's going on in F. You're literally looking at, okay, this is my F equation. What changes from here to here? using these things that you know. Okay, so I have a -4 in the exponent, so what's gonna happen to this? It goes right 4. Okay, so you're just describing if F is normal, what changes from F to G? So what changes on number 5?
It was up 6.
It goes up 6, what else? I also have a negative. Okay,
X-axis.
good. Alright, it's reflected over the x-axis. The difference between the x and the y. Reflected over the x, it'll be out front. If it's the y, it'll be right up there in front of the x. Does that make sense when I'm talking about like, so you're just looking what changes from F to G. Or they might give you G to H. Okay, so everybody got on transformations? Okay, last thing we're talking about is compound interest, and this is the stuff that actually affects your life. I mean, it may not affect your life, but I don't know many people that can pay for a house with cash, and every car they own with cash, and their whole college with cash. If you know those people, you point them in my direction. I could use a sugar daddy. Hey, get it all paid for? Heck yeah. Okay. Don't tell my husband. It's on video now. He makes really good money. Way better than I make.
Just cut that part out.
Just cut that part out. Okay, so anytime you borrow money, there's an interest rate that goes along with it. Credit cards have interest rate. Buying a car, if you don't pay for it outright and you do a loan, there's an interest rate. Your student loans, when you go to college, next year or in 2 years, there's an interest rate. Buying a house. Okay, those all work negatively against you. If you have a savings account, or a CD, or some different kinds of bonds, mutual funds that have interest rates, that works in your favor. You actually get money off of that. So if you put money in a bank, and you don't touch it, you actually gain interest off of that. I don't know if you know that or not. Because basically what you're doing is you're lending them your money. So they like give it back to you with some extras. But most of the time it hurts you. Okay, here are your 2 formulas. This one you only use if it says compounded continuously. This is the one you use for everything else. Okay, so A stands for the ending amount. Okay, P is your principal, which is your starting amount. What do you think R stands for?
Rate.
The rate. Okay, and it's going to give you to it as a percent. You need to change that into a decimal, which means you move it 2 places to the left. Any ideas what N stands for? N only occurs in the top one, not the bottom one. Okay, it's number of times compounded a year. Okay, so if it's compounded monthly, that's 12, because that's 12 times a year. Quarterly is 4. Daily would be what? 365. Okay, and then what do you think T stands for? Time, so it's the number of years. And you're going to need your calculator for this too. Everything will be rounded to 2 decimal places. Any idea why it's 2 decimal places?
Money.
Good. You guys are so smart. Not that I want to give you a big head or anything. Chloe, can you still see this on the video?
Yeah.
Thank you. Okay, so this, what are we ready for, number 6? This is how you're going to see it partially in your homework. You're going to have a chart, and it's going to give you, this gives me N, I'm going to try and find A, and then this is my P, my R, and my T. Now, I'm not going to find all of these, we'll just find a couple of them for examples. Which one do you want to find? 1, 2, 4, 12, or 365 first? 2. 2? Okay. Alright, so if I want to find N equals 2, I take everything I know. Since it's not continuous, we're going to plug it into this equation. So this would be A equals 2,500 times 1 plus, okay, 3%. 0.03. Okay, my N is 2, and then this would be 2 times T, so 2 times 20. Okay, when you round, don't round until the very, very end. Okay, what is 2 times 20? Okay, so we know this is 40. So, order of operations, say you're doing parentheses, then we're doing the exponent, then we're going to multiply. So we got to do our parentheses first. Dividing comes before adding. So we do 0.03 divided by 2. Then I would add 1. Okay, then I would use my caret button. I'm going to take this to the 40th power. And then I'm going to multiply by 2,500. I get $4,535.05. Every time it's compounded, the amount should go up. So like credit card companies, they compound their interest every 28 days, and they can get away with that because that's the shortest month. So they actually, they're making more money off of you. Instead of doing it every 30 or every 31 days, they calculate it every 28 days so they can make extra, well, some people it's a lot of money. Some people just extra pennies. Okay, so this is an example for anything other than when it says continuous. When it says continuous, you're using this formula. Okay, so let's do that one. So I would have A equals 2,500 E, and then I want R and T, so 0.03 times 20. Okay, what do you think you're going to have to do first here?
Exponent.
You're going to have to do the e to that power, right? We got to figure out what this is. So 0.03 times 20 is 0.6. So we're going to do e to the 0.6. Then we're going to multiply by 2,500. Now, if this amount is not more than that amount, you know you did something wrong. Because it should go up every single time you compound. So $4,555.30. All right, that covers everything.